Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Julio Godinez, and welcome to today's DevOps.com webinar, The Pyramid of Success for Kubernetes, brought to you by Fairwinds. We have a great webinar for you today, but before we get started, I need to go through some housekeeping announcements. Today's event is being recorded, so if you miss any part of the webinar, you will be able to access the recording for on-demand viewing. We will be sending out a link to access the webinar on demand, or you can visit devops.com/webinar or containerjournal.com/webinars. We want to hear from you, so please feel free to send in your questions at any time throughout the program by using the Q&A tab. We also encourage discussion by using the chat tab, so let us know your thoughts or just say a quick hello. We have a couple of polling questions today during today's event, so we'd appreciate if you could take a couple of seconds to submit your answers when you see those come up on your screen. Finally, stick around until the end because we are doing a drawing for 4 $25 Amazon gift cards, so stay tuned to see if you're a winner. And finally, joining me today is Robert Brennan, Director of Open Source Software, Fairwinds, Andy Sutterman, Director of R&D and Technologies, Fairwinds, and Stevie Caldwell, Tech Lead, Fairwinds. And with that, I'm going to put myself on mute, turn off my camera, and hand it over to Stevie.
Thank you. Hey, y'all. So welcome to today's webinar, The Pyramid of Success for Kubernetes. As you've heard, we are from Fairwinds, and Fairwinds is, we are Kubernetes governance and security experts. And so we're here to share a little bit of our expertise with you today. My name's Stevie Caldwell. I'm a senior SRE and tech lead at Fairwinds, and joining me today are my colleagues, Robert Brennan and Andy Suderman, and I'll let them introduce themselves. Robert?
Hey folks, I'm Robert Brennan. I'm Director of Open Source Software here at Fairwinds. I've been working in software for a little over a decade now, working in open source for about 6 years, and I've been working with Kubernetes for about 3. Really excited to talk to you all today about the Pyramid of Success.
All right, and I'm Andy, Director of R&D and Technology. I've been doing things with infrastructure since I was a kid. Been working in this industry for a while now, and I've been doing Kubernetes for, I think, about 5 years now. So super excited to talk all things Kubernetes.
So as this slide shows you, Kubernetes is the hotness, right? Lots of organizations, if they're talking about running their applications as containers, Kubernetes is part of the conversation. 87% of orgs are now managing their workloads this way. There's been an increase in Kubernetes adoption due to the digital first nature of the pandemic. And that Kubernetes adoption has shown to help companies do things like accelerate their deployment frequency, increase their automation, and decrease their IT costs. So, it makes sense and is obvious why folks are looking in that direction. So this slide actually dovetails into our first polling question, which Julio will read off for you.
Yes, you should see a polling question on your screen, and the polling question is, where are you in your Kubernetes journey? First option, I'm learning about containers in Kubernetes, followed by planning to use in 6 to 12 months. Then we have using only in testing/development environment, and I am using it in production. So we'll give the attendees a couple of seconds here to fill out their polls. And so far, it seems pretty evenly split.
I'm never sure if I'm supposed to answer.
Oh, yeah.
Still getting responses here. Wow. And as of right now, it is okay. It was at 25% for every, but so far, I'm learning about containers in Kubernetes seems to be the highest at 28. Still getting some responses. 23% have responded planning to use in 6 to 12 months. 23% responded using only in testing development. environment. Okay, and now I'm using it in production, has a lead with 30%. So thank you for participating in that. Looks all right. Excellent.
That was cool. It was like being at the races and the races and hearing people like talking about the horses. All right. So some of you may be familiar with this graphic. If you're Ted Lasso fans, this is apparently a thing that they put on their wall, like in the first episode. I've watched it and I don't remember this at all, but this is a thing. And so John Wooden's a real person. He was a UCLA coach. And apparently over a number of years, he started making a list of characteristics and traits that made a successful person. And then he pared those down to 25 and built this really clear to read pyramid that people use for reference. So we decided to riff off of that, right? And do something similar with Kubernetes, which is why we have our next slide, please. Kubernetes, pyramid of Kubernetes success, right? So for users of Kubernetes, the three basic elements for success are efficiency, security, and reliability. And so what we're going to do today is Robert and Andy are going to break down the importance of each element in the pyramid and how each builds on another to create highly functional and ultimately successful Kubernetes ownership. So we start at the base of the pyramid, and the very first thing we have here is good containerization practices, right? Because your containers are really the cornerstone of your success. There are things that you can do with your containers that help make sure that you will actually reap the benefits of running on an orchestration platform like Kubernetes. So, Andy, you want to talk about what some of those practices are?
Yeah, definitely. I'm glad our graphic's a lot easier to read than the one above it. I struggle with that. It's just too many things on it. We're going to stick to just 5 here today. So so one of the things, there's quite a few things to keep in mind when you're building your containers. And there's some really straightforward, low-hanging fruit that we can start with on the security side. Don't build secrets directly into your containers, right? Those should be injected into your container at runtime via an environment variable or a volume mount in the cluster. Don't bake those into the container. That's a fairly straightforward one that I think is easy to get done early on. And in addition to that, from a reliability standpoint, later on this will become important, but not baking config into your containers. So it should be really an immutable object. Think of it kind of like an artifact if you're thinking of older build processes where you're building, a binary and shipping it and then running it. Your container is just an extension of that process, right? It contains the dependencies, but it really shouldn't contain your config or your secrets. Those need to be injected into the container at runtime with other Kubernetes constructs that we can talk about.
Yeah, totally agree there. I think from the efficiency perspective too, I think there's a lot that you can do to really pare down the size of the container, make sure that it's as simple and lightweight as possible. And that actually also plays into security. The less you have in terms of like the overhead of, the underlying operating system, extra binaries that are installed, the less tools an attacker has if they get access to that container to actually exploit it and maybe, get inside your binary, affect its behavior, things like that. So using a stripped down operating system like Alpine instead of like Ubuntu or, one of the bigger Linux operating systems is a really good practice. If you're really a pro, you might build from scratch, in which case there's just like nothing in there for an attacker to use, not even like a shell for them to connect to. So really trying to pare down those images as much as possible will help you have small images from an efficiency perspective. It makes those images really fast to download. And then from a security perspective, it makes it really hard for an attacker to do anything.
Yeah, that's a really good point. Using that multi-stage build process. And then, like in the example of all of our Go projects, we use a multi-stage build process. We build, and then the container, in some cases, we do build from scratch, and we just put that built binary straight into the scratch container, and that's all that's in there. So the attack surface is really small. I just had another one that flew out of my head while we were talking.
Well, you touched on earlier, Andy, this idea of being stateless, injecting your configuration, injecting your secrets. And another thing I wanted to touch on in terms of reliability is just making sure that your containers are really truly stateless. If you're doing anything like storing state in memory or on disk, that can really get in the way of scaling those containers, right? You want to be able to have multiple instances of the same container, say, doing the same job, serving the same traffic, without needing to like share memory or share state between them. So pulling out that state into something like a database or something that can live outside of the container, I think is a really important part of the containerization process.
True.
That's a good point, because we've definitely seen instances where people were running one replica in their cluster because they weren't capable of running multiples, and they had to go back and refactor some things to be able to take advantage of that.
Yeah. At this point, really, we're talking not just about containerization specifically, but about application development, right? We need to have an application that can scale horizontally. And then adding on to that, another key that's going to be really important later in this conversation is having some sort of health checking endpoint, right? A status endpoint that indicates this application is healthy, it's doing what it's supposed to be doing, it's responding. That can be as simple as a 200 response on a specific API endpoint, and it can be as complicated as that response actually checking functionality of the application and returning a code indicative of that state.
Yeah, I guess just to sum up on the containerization stuff, I think the big takeaway is that it's not as simple as just wrapping your existing application in a Docker file. You're probably going to need to re-architect your app, in order to make it work well with containers.
Yeah, for sure. And then the last one I'll add that I just remembered from earlier that flipped out of my head on the security standpoint, being able to run not as root inside of your container.
Yeah.
So that's also going to be important when we go to running Kubernetes from a security standpoint. But if your application has to run as root, you're not going to be able to deploy it in a way that doesn't run as root.
Yeah.
Right.
Yeah, that's a good point.
So, yeah.
Cool.
All right, so the next topic, or the next layer of our pyramid, is about building and pushing containers. So we've done all these great container practices. We've got it running not as a root user, as a non-root user. We don't have any state stored in there, so we can run multiple replicas. Now we need to build our container and push it somewhere. Robert?
Yeah. So I think the first thing I would recommend is building and pushing your containers on really every commit or every branch that goes into your repository. So having like a CI/CD process set up that's going to build the container, make sure it builds properly without failing to compile or something like that. And then storing those Docker images so that a developer can deploy a like a QA branch for their application, so you can have like kind of a testing environment. Having a record of kind of for every commit in the repo, knowing what did the application look like at that point in time. I think tagging with the commit hash is a really good idea, just so that you can easily track, this Docker image in my Quay registry or Docker Hub registry matches this exact commit in my Git repository. Having that one-to-one mapping can be really helpful for debugging and just understanding what's going on.
Yeah, and on top of that, avoiding overriding tags. So having in a lot of repos give you the option to set the immutable tag option. ECR, I know for a fact, does. Not that actually is a security thing as well as a reliability thing, understanding where exactly the code is that built this artifact, but then not being susceptible to an attack that injects a malicious container into your registry with that tag via that immutable tag option. It's a great thing to do for sure.
Yeah, that's a really good point. It makes it a lot easier to audit too what happened in your registry if something does go wrong. Knowing that this tag didn't flip around is really helpful.
Right.
And what do you all think about scanning your images when you push as well for security vulnerabilities?
Yeah, that's a really good point. There are some great databases out there of known vulnerabilities inside of common libraries, which may or may not be packaged inside of your container and may or may not be exploitable. There are some great open source tools for basically taking that big database of vulnerabilities and scanning your container for anything inside of that container to understand whether those vulnerabilities are present. A lot of registries will build in some kind of container scanning into their registry, which is great. It's really nice, but doing that scanning as part of your CI/CD process is actually even better, because you can basically break your build before that vulnerable image gets pushed into the registry and can potentially get used. You can stop the process and say, don't push this image. It has a known vulnerability.
Yeah, definitely. To clarify what I said earlier, having immutable tags is a good thing. I just saw that pop up in the chat. So immutable tags in your repository is a good thing, as is scanning your containers. And then the last thing I'll add, we'll talk about the last side of the pyramid, the efficiency piece, is utilizing Docker's caching in your build process can be super helpful, especially when you're doing those multi-stage builds that we talked about. If you cache every stage of that and you push it into your repository, a lot of times pulling down that big build image is faster than rebuilding it every time. And so, Docker has that built in a lot of good ways. And there's lots of different ways to utilize it, but definitely take advantage of caching, because that build process can get long if you have a large dependency tree, for sure.
Yeah, that's a great point. I think that containers do add some extra steps to the build process. And so if you don't do things well, it can really slow down the development loop. So I think you make a really good point there. Another thing that popped into my head that kind of sits on the border between good containerization and good container building practices from a reliability and efficiency perspective is as you're building your application, copying the dependencies over before and installing those dependencies before you copy your source code over to the container can really speed up the build, because Docker can cache all those dependencies, which aren't going to change very often, whereas the source code is going to change very frequently. And that way, as you're building your container, that kind of expensive step of installing all your dependencies can get cached nicely. And you don't have to repeat it every time that container builds.
That's right. Put your package.json copying before you do your NPM steps, for example.
Exactly. Yeah.
Definitely.
Cool. All right. So then the next layer in our pyramid is probably one of the, I would say, like the largest scoped things that we can talk about here today, because there are so many Kubernetes objects and concepts that go into deploying your container that hit all three sides of these pyramids. So let's get into it. Andy, you want to start?
All right. I'm gonna say the thing that I'm hopefully, if I become famous for anything, it will be this: set your resource requests and limits. That is the number one thing for both reliability and efficiency that you have to do when you're deploying into Kubernetes. And I know I sound like a broken record. I know Robert and Stevie, you've heard me say this 1,000 times, but we still we still see it in the wild, people deploying containers without those resource requests and limits. And that is the cornerstone of what makes Kubernetes able to scale well. It makes it able to bin pack well. And it also enables you to, run your containers in a way that they're not going to just fall over all the time.
Yeah, that's a great point. It's I think a theme around deploying into Kubernetes is that Kubernetes tries to make your life easy and make it so you can deploy with a very minimal configuration, and they'll let you not specify things that you really should be specifying. So memory and CPU requests and limits is a big piece of that. Also readiness and liveness probes to make sure that your application is actually healthy. There's a lot of security stuff that isn't exactly secure by default. There are ways to tighten the security using your configuration. So just relying on the default configuration is a good way to shoot yourself in the foot. You really have to know what are the things you should be specifying, even though the Kubernetes API will happily let you not specify them.
Definitely.
Yeah, that's correct. Security context, which you touched on there, is like a big one for obviously the security portion of it. Making sure that you set your appropriate Linux capabilities, making sure you set it, your run as root and allow privilege escalation, all that stuff should be taken care of in your deployment. So that's super important. Yeah.
Yeah. Yeah. And then something we talked about earlier comes into this again, both from a security and a reliability standpoint, using specifically tagged images. So not using, something like latest or, just a V1 tag. Hopefully you're, we suggested earlier tagging with that git SHA of the commit that built the image. Use that in your deployment process as well to know exactly which commit was deployed for this particular version of the application. And that's a really important thing.
Yeah, that's a really good point. The other thing I was going to add. Go ahead, Stevie.
No, you go, Robert.
I was going to say, in addition to configuring the deployment itself with resource requests and limits and things like that, there are also kind of secondary resources you can put alongside your deployment, like a horizontal pod autoscaler, pod disruption budget, things like that, that can help Kubernetes understand how your application scales up and down, what it should do, in the event that, say, you're upgrading the cluster and you need to start, pulling out old nodes and sticking in new nodes. These extra resources can give Kubernetes hints as to basically how to run multiple replicas of your application.
Yep. That's what I was going to say. And in addition to that, also still within the actual deployment objects, there are a bunch of things that you can manipulate to sort of, help out the reliability of your application. Things like, whether you want to make sure that your pods aren't all getting if they shouldn't get scheduled together, for example, like you don't want a number of Nginx pods scheduled on the same node in case you have to drain that node. Things like quality of service settings, we do sometimes set your memory, your request and your limits to be the same to guarantee that that process is least likely or won't get bumped from a node if it becomes constrained in some way. There are all kinds of things that you can do at the deployment level as well to affect the reliability of your deployment of your application.
Definitely. And then to continue to build on the things we talked about earlier, we talked about not building your config and your secrets into your container. This is where you start talking about how you get them in there. So, your non-secret configuration, you can keep in a config map and then pull those in as environment variables into your application or however they need to be consumed, as a config file or environment variables. And then secrets, at the bare minimum, utilizing those Kubernetes secret objects to inject your secrets into your container. And then if you need a higher level of security, looking at something like Vault and a Vault sidecar to inject those at runtime and pull them directly from your Vault. And there's lots of other solutions out there as well to do secrets management, but being extra careful of those.
Yeah, that's a great point. I think secrets are an easy thing to screw up in the deployment process. One of the patterns that we like to utilize is using SOPs to basically allow you to store your secrets in infrastructure as code, which gives you a really good sense for when they change, how they're changing, things like that. But to encrypt them in that infrastructure as code, so they're not exposed to anybody who has access to the repository. You need some kind of master key in order to decrypt the secrets and actually see what's in there. That's a really I've found that very useful for tracking those secrets without exposing them.
Yeah, definitely. And it allows you to keep, finally control who has access to the secrets and where by using different KMS keys or using a Vault Transit backend to have that fine-grained access control over who has access to those secrets.
Yeah.
All right. Should we move on to the next layer? Everyone's favorite, monitoring. That is to say, not everyone's favorite, actually. So we've got our stuff running in the cluster. We've done all these great things, and dang, we forgot to instrument monitoring for our application. We don't have any sort of baseline information about how our application's running, and that's a big deal. So you want to have monitoring in the forefront of your whole strategy. Like you want to, because you do get the baseline information that you can get from monitoring early on in your process is very helpful to understanding if your application is misbehaving in some way and for seeing anomalies and things like that down the line. You really want that historical data. So, Robert, I'm going to tag you next. Let's talk about monitoring.
Yeah. So like you said, super important. It's really easy to just say, well, my application's working, people are using it, no problem. I can just, let it run. And then, all of a sudden something goes wrong, the website goes down and you have no idea why. You had no heads up that something might be going wrong. And, it's a very common pattern, honestly. You don't fix it until it's really broken. So getting a good monitoring and plan ahead of time is super important. At the very least, you should be sending your application log somewhere that's long lived, so that you have a record of what's happening, and you can start pattern matching on those logs to see if there's a sudden spike in error or warning logs, things like that. If you're serving HTTP traffic, understanding what the status codes are like, making sure 500 errors or something you're alerting on, making sure any kind of unexpected error is getting alerted on, all super important.
Yep, definitely. And then from an infrastructure level, monitoring, different pieces of your cluster, right? Understanding that things are behaving the way they should. You don't have a large number of pods pending in your cluster. You're not maxing out your scaling groups. You're using the cluster autoscaler and it's functioning. Monitoring for simple functionality across it, not going too heavy on, I don't want to know every time a pod restarts, right? Pods restart, that's expected. But if a pod's been restarting, 20 times an hour for the last week, I'd like to know that. Yeah. And things like that. So
yeah, tuning that verbosity in your monitors can be really difficult because you don't want to miss an actual production issue, but you also don't want to fatigue your team to the point that they start ignoring the alerts, right? That's right. So figuring out exactly what the right trade-off is there can be really difficult.
Yeah.
And should we have called this monitoring and logging? Because I think part of this should be potentially sending your Kubernetes event logs someplace, because those are short-lived in the cluster, right? So if you're trying to track down some really hairy situation, some really hairy behavior, you only have a very short period of time in the cluster to do kubectl git events. Whereas if you ship them off somewhere,
Mm-hmm. Yeah. I'll dovetail off that to answer a question that just came up in the chat about monitoring solutions. We use Datadog fairly heavily. And one thing that I really like about Datadog is that it lets you overlay a Kubernetes event search over a graph. So if I'm looking at a graph of, latency over time or maybe, latency over time, and I notice there's a spike, I can overlay Kubernetes events and see, okay, maybe we did a deployment at that time. Maybe, a bunch of pods became unavailable at that time for some other reasons. Maybe that node was drained and my probes aren't working properly. So my application, I was routing traffic to pods that weren't ready to receive traffic or something like that. And the event stream can really be helpful with that. And also a good point, observability, monitoring, logging, and, if you're feeling really, what's the right word here? Fancy. Tracing can be a useful thing for sure. Yeah. But I think having that monitoring and logging in place first is more important than having tracing. It can definitely be helpful, no doubt. But
I would agree. It could definitely alert you to security issues if you see some anomalous behavior in your logs, for sure. Yep. But speaking of security, how is it important to make sure that your applications aren't sending secure information in its logs? Where do you set that?
Yeah, that's definitely a something that's worth keeping in mind. You don't want to be logging users' tokens to your logs and things like that. It's probably not the most that those logs are hopefully only an internal thing, but typically everybody in your engineering organization is going to need access to those logs. And so it makes it really hard to have a sort of principle of least privilege, any kind of like access control type stuff if you're logging those things into those logs. So, keeping secure information out of there in a place where, only the people who need access to it have access to it, I think is important.
Yeah, definitely. I think we could go back to the beginning of the pyramid here and good containerization practices and talk a little bit about logging, making sure you're logging the standard out, just standard Docker practice, being able to get those logs in an easy manner, but then not logging secrets is, definitely super important. And it's an easy thing to do when you're developing and you're struggling with a problem and you want to see what's going on, but you got to remember to not do that in production for sure.
Yeah.
Just real quick, there's a question that I see in the chat about just sort of clarifying what the solution was for secrets, putting the secrets in the Git repo. And I think that's going back to maybe talking about what Robert was saying about using SOPs to encrypt your secret before you put it in the repo. And then SOPs uses a KMS key with an ARN to encrypt and decrypt that secret. So when it's in your repo, it's encrypted and it only gets decrypted when it gets applied into your cluster. Is that about right, Robert?
Yeah, that's exactly right. It's SOPS if you're looking for it. It's a project from Mozilla.
Yep. I'll drop a link in the chat. But it can use Google KMS, Amazon KMS. It can use a GPG key. It can use Vault Transit backend. There's lots of different ways to work with it.
Cool. All right. So now we're at the very top, the pinnacle, if you will, of our pyramid. Optimize. And that's so perfect because it is the pinnacle and optimization feels optimal, which feels top. I'm just riffing on this word here. Forgive me. Let's talk about optimization, optimizing your workload. Now that it's all deployed, you've got all your monitors set up. People are only getting woken up for really important stuff. And now we're going to optimize it. Andy.
Ooh, this is a good one. I mean, these top three pieces, actually this whole thing should have like one of those little circle arrow diagrams around it, right? Because you're going to change things in your containerization practice. You're going to build and push, you're going to deploy, you're going to keep watching, and then you're going to optimize, and you're going to come back. But anyway, things that are relatively easy to watch for over time with good tooling, making sure that your resource requests and limits are appropriate, that they're not over provisioned, right? You may build a container and think it needs 6 gigs of memory when it needs 1, and you can, turn that down over time. So there's tools out there to help with that. A couple that we have, open source, we have Goldilocks. Our Insights platform integrates that as well, and also integrates Prometheus metrics. But keeping an eye on, limits versus how much we're actually using over time. Requests and limits versus how much we're using over time. Is an important, good first step on optimizing for efficiency. So I get back to one of our sides of our pyramid there.
Yeah. Just speaking from a developer's perspective, I know in the past, I've definitely I just want my application to work. I don't really care how efficient it is. So I'll just give it way more memory and CPU than it actually needs. And, it runs fine. And then I look at those graphs inside of Goldilocks or Insights and I see, oh, wow, I'm using like 10% of what I asked for. So it's important to keep an eye on that because you do end up with huge cost overruns if you don't pay attention to it at all. It's a very easy thing to just kind of forget about because everything seems to be working.
Yep.
And then I think the other piece of the optimization track is something we touched on a little bit in the deployment process is you want to understand, kind of that horizontal scale as well, in addition to the memory and CPU amount that you're using vertically. How many replicas are you running? How many do you really need to be running? How do you scale up and down? When do you scale up and down? I think the most natural way to scale up and down is if your existing replicas are using too much memory and CPU, you might scale up on that, basically on that resource usage. But you may also have other custom metrics like, the size of a queue for a job that's like processing things off of that queue. If that queue gets really deep, you might want to, increase the number of workers. You might want to scale based on the amount of HTTP traffic you're seeing, things like that. So knowing how to scale up and down intelligently and tuning that over time is really important.
Yep.
Definitely. Another thing from the security perspective is, we talked about scanning for CVEs in your build process, but the next thing you have to do is scan your already running containers in your cluster for those CVEs, because they get released all the time. They come up after you've deployed. Maybe it's something you don't release very often, and a new CVE is announced for something that's already running in your cluster. You want to be able to see that and have visibility into that. So one of the open source tool we talked about earlier for scanning in your CI/CD platform will also work in your cluster, and that open source is called Trivy. I think I spelled that right. I'm putting these in the chat by request. So which we also integrate Trivy into the commercial platform Insights that we mentioned in the line above that. So
yeah, there is a lot of fine tuning you can do, I think, on the security side too. There's anybody who's run a production server for long enough has seen some like automated attacks just come in and try and see if they're running a vulnerable version of WordPress and things like that. So figuring out basic rules for blocking traffic, setting up a WAF or something like that to make sure that, anybody who's obviously just snooping around for a vulnerability ends up getting blocked. Things like setting up rate limiting properly to make sure that somebody who's scraping for user logins and stuff like that gets blocked pretty quickly. All really important things that do need to be fine tuned over time, right? You don't want to block too aggressively and end up blocking out a legitimate user, but you also want to make sure that anybody who's actually trying to attack you gets blocked out pretty quickly.
Definitely. And also optimizing your process here is something we can talk about, because there are ways to, integrate checks for security into your deploy process, for example, like by using an admission controller and saying you cannot deploy something that's allowed to run as root into this cluster, and really optimizing the entire process and then the entire workflow is something that can be really useful. I feel like even though optimize is the smallest part of the pyramid because it's at the top, it's actually the biggest topic, because there's so much you can do to make all these different pieces easier and more efficient and more reliable over time. So, and more secure. So,
yeah, that's a great point.
Yeah. Okay. I think we've reached the end of our pyramid. And so now I'm going to turn this over to Robert to give you all some more information about Fairwinds Insights and how we help you ascend that pyramid.
Thanks, Stevie. Yeah. Insights is a commercial platform for doing Kubernetes governance and security, all the way from CI/CD as your developers and ops teams are making changes to their code base, through admission control, so kind of stopping things as they are trying to enter the cluster, and then scanning that running production cluster or staging cluster to make sure that things that are in there are adhering to your policies, best practices, and security practices. Basically, the way Fairwinds Insights operates is we integrate all the best-in-class open source that's out there. Some of that's our open source, projects like Polaris and Goldilocks, which we've touched on. Also projects from other organizations like Aqua Security's Trivy project for container scanning. Basically, we take all this great open source that the Kubernetes ecosystem has built, and we put it behind a single pane of glass, so you can do your container scanning and check your policies for best practice, or check your Kubernetes configuration for best practices. You can apply policies with OPA or Open Policy Agent. You can take all this great open source and kind of put it all together, run it across multiple clusters in a very consistent way. It's really helpful if you've ever tried to kind of deploy this open source in a kind of a one-off basis. Fairwinds Insights really kind of simplifies that process and makes it easy to operationalize that open source. So there's really three aspects of Fairwinds Insights. One is the security angle, as well as compliance. We can really help you make sure that you're not running images with known vulnerabilities. Make sure that your Kubernetes configuration is adhering to security best practices, like disallowing running as root and not having writable file systems, things like that. And we can help you really ensure that you're adhering to both any internal compliance standards as well as like any standard compliance standards like SOC 2 or HIPAA, ISO. We provide a lot of checks that map nicely into those different security standards. Then from a cost and optimization perspective, we do monitor your memory and CPU usage over time for each workload and keep track of that versus the memory requests and limits. As we were saying earlier, it's really easy to over-provision those things. We also see them under-provisioned sometimes. So making sure that you get those requests and limits, in a nice place is super important. And we basically give you a way to mark each workload as, this is a production, mission critical workload, or this one's just a development workload. I don't really care so much about it. You can mark those in Insights, and we'll give you recommendations for where you should be setting your memory and CPU based on what we've seen that application consume over time. And then the third piece is really around policy and guardrails. This is about, if you have any compliance standards that you need to adhere to, if you have any internal standards, like maybe a labeling scheme, or anything that you want to enforce across all your development teams, we provide ways to basically create that policy, mainly using OPA's policy language called Rego. And to apply that as guardrails. So you can apply it in the CI/CD pipeline to make sure that any infrastructure as code adheres to that policy. You can apply it again in admission control to make sure that anything that's coming into your cluster adheres to that policy, in case maybe somebody, force merged something in Git, or if they, kind of skipped the Git process and did, a kubectl edit, or, just did a kubectl apply on something to get something into your cluster without doing infrastructure as code, which is a big no-no in our book, but it does happen. And then finally, you can apply that policy to resources in the cluster, which makes it really easy to roll out new policies. You can quickly see, what resources are currently in my clusters that would break this policy. It's really nice being able to take the same policy and apply it at all 3 points in the process. So I have a quick demo of Fairwinds Insights. I'll share my screen quickly. So this is Fairwinds Insights. You can see on the main page here, I have a list of clusters in my organization. This Centaurus organization has 2 clusters, one called Proxima Prod, their production cluster, one called Alpha Staging, their staging cluster. I can see how healthy these clusters are, how many action items are inside these clusters. These are basically things that we've found that they could be doing better. We can see their health scores change over time, getting slightly better over time. And we get an overall score for the cluster. We can see we've got a bunch of passing items, about 1,600 things that Insights is checked for, that they're doing well. But in addition to that, a bunch of action items here ranging from different levels of severity. A few critical items, a few high items, a good chunk of medium level items in here too. So we can click into one of these clusters and see how things have changed over time. It looks like this is a pretty quiet cluster, but a critical action item was introduced a couple weeks ago. We can see the health score has been pretty stable, and then we can see kind of a list of the top issues that are in this cluster. It looks like the most common issue is vulnerable images. Again, this is something that Trivy is checking for. It's scanning those clusters for known CVEs. There's a bunch of other things that Insights checks for, like best practices, like not having your pull policy set to always, not allowing privilege escalation, not giving your containers insecure capabilities, running as high user IDs, things like that. So we can click into these to see exactly what's going on here. We can see we've got some vulnerable images. We can click into each one of these and see what exactly is going wrong inside of this image. I can click out of this and get a broader view here. We've got projects like KubeBench, which show basically like how you adhere to the SIS benchmark, which is a common benchmark. You can see there's some action items from that. Really, there's a whole bunch of different things that Insights can check depending on which of our reports you decide to install. This is really where you can configure exactly what it is you care about, what it is you want to check. We try to integrate all the best-in-class open source software out there for scanning Kubernetes clusters for issues. You can see some of these are our projects like Polaris and Goldilocks. Some of them are third-party projects like Trivy and Open Policy Agent. And each of these kind of does one thing well. Polaris is all about deployment configuration and best practices there. Trivia is all about scanning container images. Goldilocks is about setting memory requests and limits, CPU requests and limits properly. OPA is about policy enforcement. Nova, make sure your Helm charts are up to date. Pluto's for deprecated resources. Each of these really focuses on one task, and you can kind of pick and choose which ones work for you. We talked a bunch about doing CPU and memory resources properly. We have this workloads tab to really show you, what your costs are over time. This is a pretty stable cluster, so you see a pretty straight line here for memory and CPU. But you can click into each one and understand, okay, what are my requests and limits set at? What should they be set at? You can see for this workload, we're actually recommending that they tune down their memory a little bit from 512 megabytes to 322. They can save a little bit of money doing that. You can see also for CPU, we're actually tracking the usage over time, so you can actually see, okay, how much am I actually using? We can see this workload. The reason we're recommending 322 megabytes is that generally speaking, it's well under 300 or so. Usually it seems to be sticking around 330. So we're recommending, a request of 322 and then a limit of 360. So that's our way of kind of helping folks really right size these resources and figure out, okay, what should I be setting as my CPU and memory requests and limits. I think that's about it. There's a lot more I can go into, but it's a very big platform at this point. We do things like policy enforcement. You can get a view into role-based access control and how well you're doing there. You can see a list of add-ons like Helm charts that may or may not be up to date. You can view a list of admission controller events, see when things were rejected, when things were allowed into the cluster, and see a list of things that could be going better there. It's taking a second to load. It's an easy way to get a sense for, what's being allowed into your cluster, what might be getting rejected. Hopefully that was helpful. I'll go back to the slides. I think we have one more polling question for y'all.
Yes. So the second polling question, what is your greatest opportunity to improve your Kubernetes environment? A, getting help with the basics. B, general best practices assessment. C, improving the security posture of your clusters. D, saving money. And E, improving the reliability of apps running in Kubernetes. So seeing responses coming in, that's great.
Nobody wants to save money.
So far, it doesn't look like it.
No, it's like Robert said, you start off just like throwing everything on the largest instances you have just to get it going.
It's not until your CFO yells at you that you start thinking, oh, okay, maybe I should take a look.
Right.
You mean I don't start with M5 24XLs? Why not? Come on. Every app gets 4 gigs baseline.
All right. And so far, 40% have said getting help with the basics, 30% general best practices assessment, 10% improving the security posture of your clusters. Still nobody on saving money, 0% there. And 19% improving the reliability of apps running in Kubernetes.
I'm surprised to see that getting help with the basics is the highest, considering the results from the first poll, where it was evenly split between everybody, almost evenly split between the phase of the journey.
Yeah, I think running in prod actually came out highest at the end of that first poll.
Did it?
So, yeah. So that's pretty interesting.
The basics are hard. You got to get the fundamentals right.
That's true. Oh, no, I didn't.
Cool. Well, so we have here a white paper on Kubernetes best practices. So for those of you who did want help with the basics, I think this is a great piece of reading material for you to understand. Okay, what are best practices? How do I, best implement those best practices? Make sure they're followed going forward by each of my development teams. This is a great kind of overview of those best practices. And we'll leave this up, I think, while we do some Q&A.
Absolutely, yes. We do have a couple of questions, and just as a reminder, if you do have a question for our panel here, you can do so by submitting them in the Q&A section. And this was a question from a little bit earlier. It says, I didn't understand, is the immutable tag a good thing or a bad thing?
Definitely a good thing.
Mm-hmm.
That's
Excellent.
an easy one.
Excellent.
Keep them coming if they're that easy.
Okay. We also had, can you compare your solution to Aquasec and to Alert Logic?
Yeah, so I would say the main differentiator with Aqua is that we're a very open source first platform. We basically, rather than building a bunch of proprietary logic, we recognize that the Kubernetes ecosystem has really done a tremendous job of building open source tools that do the work of detecting security events, detecting efficiency and reliability issues. They're just really hard to operationalize in practice, which is why people opt for a commercial platform. There's a cost to using open source that is really hard to quantify, but once you actually start trying to use it for a production use case, it becomes really obvious that you're spending a lot of time maintaining your integration with that open source, making sure that any new use cases get supported, et cetera. So it really does make sense to kind of bring in a commercial partner to help operationalize that open source. So I think that's our big differentiator. I don't know a lot about Alert Logic, but my impression is that they're really more of like a white glove security vendor, that they're much more kind of services driven and much more security focused. Both of those companies are much more just plain old security focused, whereas we really try to be a holistic window into how healthy is your Kubernetes environment, not just from a security perspective, but also from an efficiency and a reliability perspective. Are your applications going to crash? Are they going to scale properly? Are you spending too much money? Are you not allocating enough resources to those workloads? Those are all questions you can answer with Fairwinds Insights.
Excellent. Next question here. Is there any chance to share the price for Fairwinds Insight? Is it per cluster?
I believe we generally charge per node. I think you'd have to get in touch with our sales team for actual pricing, though. It tends to differ from organization to organization, depending on your use case, et cetera.
All right. Still have time for a couple questions here. What's the most common security mistake you see most clients make?
It's a good question. There's a lot.
Yeah, I feel like not setting a security context on their pods or at the container level is probably one of the most basic ones.
Yeah, I would agree with that.
Having some kind of policy in place that kind of forces people to do that, because it is an optional thing. You can totally, Kubernetes will happily accept a deployment without a security context. So having some kind of, policy and guardrails in place to make sure people are setting that, especially if you've got like a multi-tenant type environment where you have multiple different development teams all shipping into the same cluster. It can be hard to do code review on every single change they make.
Excellent. Next question. What should you look for first when you try to cost optimize your clusters?
Do I get to be the broken record again and say resource requests and limits?
Do it.
That's going to be my thing. I'm going to be the Kubernetes resource and requests, limits and requests guy. Yeah. So yeah, definitely like checking to make sure that you're actually using what you think you need.
Yeah. So. Yeah. And once you do have those set, my big thing is just looking at for each of your nodes, are you using all your memory or all your CPU? Like, where are you more constrained, memory or CPU? If you're using up every ounce of memory you have and have a bunch of leftover CPU, you might want to change your node type in order to get memory optimized nodes, or vice versa. If you're using a lot of CPU, figuring out what the right node type for you to run on is, I think makes a lot of sense.
Yeah. And then the next easiest thing is, utilizing spot or preemptable instances, specifically in your non-prod environments first. But, if you have all of your reliability pieces buttoned down, it is a perfectly viable option in your production environment as well for a lot of use cases.
Okay, and the last question I see here, how many clusters could you have to benefit from insights?
Yes.
Yeah, I think Andy's right. Even just a single cluster, it's helpful. I think the big place where you start getting huge benefits from insights is if you're a really small company with one engineering team that's doing all the ops and development. It's probably pretty easy for you to keep an eye on things, in that one cluster, one team, et cetera. The second you have multiple teams deploying into Kubernetes, or you have a dedicated ops team separate from the development team, things start to get, you start to really need, better visibility into what's happening, a better platform for communication between those different teams, especially if you have many different development teams. Things get out of sync very quickly, and you really need eyes on that. So the second you reach any sort of scale, it's good to get a commercial platform in there to help you, understand what's in there. But even in those early days, it's good to kind of establish those practices at the beginning to understand, so to know that you'll be able to grow into positive practices rather than trying to layer them on after the fact.
Yeah. I really like that distinction of the multiple teams. I think, we draw the line at clusters too often. It's really, I have talked to a company that has one cluster for dev stage and prod, but they have 30 different teams deploying into it. And so, that's a very different scenario where insights can be super helpful in a single cluster versus multi-clusters, and most organizations will have, a prod and a non-prod cluster at, minimum. Most. So.
Excellent. All right, we are nearing the top of the hour. So quickly, I just want to say that today's webinar has been recorded. So if you missed any or all of the webinar, you will be able to watch it again. We will be sending out an email with a link to access the webinar on demand. You can also find it on devops.com or containerjournal.com. Just look in the on-demand section in the webinars page, and it should be there. We also did have the 4 winners for the $25 Amazon gift card. Our first winner is Eduardo C. So congratulations, Eduardo. Our second winner is Christopher M. So congratulations. Third winner is Sitaram S. And finally, Yaroslav S. So congratulations to all our winners. We'll be reaching out to you with an email with instructions for claiming your Amazon gift card. So please check your inbox. And if you don't see it there, check your folder. Robert, Andy, and Stevie, thank you so much for taking the time to put this presentation together and demo. We all appreciate it.
Thanks, Julio.
Thank you.
Thanks for having us.
Yeah.
Of course. And finally, thank you to the audience for their time and engagement. This is Julio Godinez signing off until next time. Be well.